All right, today we are diving deep. We're going to travel back in time, like 4,000 years back, to unpack the incredible story of one of the most powerful tools humanity ever invented: algebra. We've all been there in math class, right? Staring at that letter X. It's always the unknown, the mystery we need to solve. But have you ever stopped to think, why X? Why not Q or Z or something else? Well, that little question is a doorway into a much, much bigger story. And don't worry, I promise, we'll get you the answer. And listen, this is not your high school math class. Nope. This is a story about human ingenuity. It's about how our brains literally evolved from using entire paragraphs to describe a problem to creating this sleek, powerful, universal language. A language that, by the way, is running pretty much everything around you right now: your phone, the internet, even how we map out the cosmos. So, ready to jump in? Here's our roadmap for this amazing journey. We'll kick things off way back in ancient times, looking at how algebra was all about words. Then we'll see how that started to change with the first bits of shorthand. After that, the big one, the symbolic revolution. We'll also get into how algebra went from just solving things to understanding deep structures. And finally, we'll bring it all home and talk about why it's still so incredibly important today. All right, let's start at the very beginning. Our first stop is what's called rhetorical algebra. And I want you to completely forget everything you know about equations. No X's, no plus signs, nothing. This was a time when math was literally literature. It was all about words. And this timeline right here gives you a bird's eye view of what we're talking about. We're starting way, way back around 2000 BCE in Babylonia. And you can just see these huge jumps in thinking, from ancient priests to brilliant minds in Greece and the Islamic Golden Age, all the way to the Renaissance in Europe and into the modern day. It's quite a ride. So what is this rhetorical algebra thing? Well, it's pretty much what it sounds like. Every single math problem, the numbers, the operations, the unknown, was written out in plain old sentences. I mean, can you imagine? Instead of just scribbling down a few symbols, you'd have to write an entire paragraph just to state the problem. Check out this quote from the legendary Persian mathematician, Al-Khwarizmi. This really paints a picture. All of that 1 square and 10 roots, that whole long sentence, you know what that is? That's just a fancy, old-school way of saying x squared plus 10x equals 39. It's kind of poetic, right? But man, you can see how clunky and difficult that must have been to actually work with. But here's the crazy part. Don't let all the words fool you. These ancient thinkers were incredibly sharp. The Babylonians came up with this genius method called completing the square. You can see the steps here. They basically had a recipe. Take half the number of roots, that's our x term, square that number, add it to the other side, and boom, you've just created a perfect square. It's this super elegant trick that makes finding the answer a breeze. We're talking brilliant, step-by-step logic, all figured out thousands of years before a single calculator existed. Just wow. Okay, so after centuries of writing out mathematical novels, you can probably guess what happened next, right? People got tired of it. They started looking for shortcuts. And that leads us to the next chapter in our story, the dawn of syncopated algebra. Syncopated algebra is basically the missing link. It's the bridge between those long, flowery sentences and the clean equations we use today. You can think of it like mathematical shorthand. A brilliant Greek mathematician named Diophantus was one of the first to really run with this, using little abbreviations for common terms to speed things up. And this comparison right here says it all. Look at this. At the top, you've got the full-blown sentence from the rhetorical age. Then in the middle, you see the syncopated version, a kind of hybrid with abbreviations for words like square and roots. And then at the bottom, there it is, the sleek, powerful, symbolic algebra we all know. You're literally watching human thought get sharper and more efficient on a single slide. And that brings us to the main event, the big one, the symbolic revolution. This is where algebra finally becomes the powerhouse tool that we recognize today. So where did we even get the word algebra? It's a great story. It actually comes from the title of a revolutionary book written back in 820 AD by that same Persian mathematician we mentioned, Al-Khwarizmi. His book, which had Algebra in the title, was so important, so foundational, that it didn't just give the field a name. It basically created it as a distinct subject of study. And what does algebra mean? It literally means restoration or completion. It's talking about that move we all learn in school when you have a negative number on one side of the equation, you restore balance by moving it to the other side and making it positive. That's it. That's algebra. His book was all about laying down the rules for how to do this stuff, how to complete and balance equations. So this actually sparks a pretty cool historical debate. Who really gets to be called the father of algebra? Is it Diophantus, the Greek guy who started using symbols? Or is it Al-Khwarizmi, who was the first to treat algebra as its own thing, a whole system for solving problems? It's a tough call, right? What do you think? But no matter who gets the title, the algebra we use today, the fully symbolic stuff, didn't really take its final form until the European Renaissance. You had guys like Francois Viette, who started using letters in a more systematic way, but the person who really cemented the system we all learn in school was René Descartes back in the 17th century. And here it is, the moment you've been waiting for, the answer to our very first question. In his massively influential book, La Géométrie, Descartes set up a convention. He said, let's use letters from the beginning of the alphabet, A, B, C, for the numbers we already know. And for the ones we don't know, the unknowns, let's use letters from the end of the alphabet, X, Y, Z. So, why X? Honestly, nobody is 100% sure, but the most popular theory is a practical one. French printers at the time just had more X type blocks lying around because it's not a very common letter in French. And just like that, because a printer might have had extra stock, X became the universal symbol for mystery. Kind of funny, right? But believe it or not, the story doesn't end with finding X. In the 19th century, algebra took another turn, a really profound one. It went from being a tool for solving problems to something else entirely. Yeah, the whole focus just pivoted. Instead of just asking, what's the answer? Mathematicians started asking, wait a minute, what's the underlying structure of this whole system? It wasn't about finding X anymore. It was about understanding the very rules of the game itself. And this gave birth to a whole new world called abstract algebra. It sounds intimidating, but the core idea is about studying these fundamental structures, which they gave names like groups, rings, and fields. Let's take groups. All that is, really, is a set of things, they could be numbers or actions or whatever, that follow a few simple rules for how they play together. Like, think about a square. The set of all the ways you can rotate it or flip it and still have it look like a square, that's a group. And by studying these abstract ideas, they started seeing these mind-blowing connections between totally different areas of math. So, okay, we've just gone on this wild 4,000-year ride. Why should you care? Why does any of this matter now? Well, because that final leap, the one into abstract structures, is the exact reason algebra is, quite literally, the language that our modern world is written in. I mean, just look at this list. Computer science, physics, cryptography, finance. It's all built on algebra. Let's just take one, cryptography. The fact that you can buy something online securely with your credit card, you can thank abstract algebra for that. The security is based on the mathematical properties of those groups we just talked about. They're used to create codes that are super, super hard to break unless you have the secret key. That is abstract 19th century math protecting your data right here, right now. It's amazing. When you step back and look at it, the story of algebra is really the story of us. It's our own journey of learning how to think. We went from solving everyday problems with words to inventing a universal language of symbols, and then to exploring the very fabric of logical structures. It's the story of how humanity learned to wrestle with the unknown and wing. So from words to symbols to deep fundamental structures, it's been one heck of a progression. Which leaves us with one final big question to chew on. As our world and our problems get even more complex, what's the next evolution going to be? What's the next stage in how we reason about the great unknown?